Yes, thank you very much, Dave, for that very nice introduction.
I didn't write it. I thought you did.
What's that?
I thought you wrote that.
Well, thank you for the presentation. Okay. Hello, everyone. As Dave already mentioned, my name is Ken Rogers. I work as an IT business analyst at PNC Bank, and I live in Ohio with my wife and kids and 2.4 lawnmowers. And yes, that's a picture of me with a fencing helmet on my head. I like to play with pointy weapons. Today's topic is about home networking. Most of this presentation is going to be about wireless networking, because when most people talk about networking in the home, they're talking about wireless networking. So I'm going to be spending the majority of the time talking about wireless. There are two specific topics I want to talk about with wireless networking. First of all, security, where a lot of what I'll be doing in this presentation is going to be expanding on the earlier presentation, which was more on antivirus and anti-scamming strategies for individual computers. But I do want to talk a little bit about specific topics in wireless security. There are two commandments that I'm going to give you about wireless security, and if you get nothing else from this presentation, I want you to remember those two commandments, and I will get to them very soon. There are also three myths about wireless security that I want to address. These myths are, if you do a Google search on wireless security, you may find a article that advocates pursuing one of these additional security features that are available for wireless networking. And I'm going to talk about why you should not employ any of those additional methods. After talking about security, I do want to talk about improving wireless performance in the home. If you have a wireless LAN, you've probably experienced some frustrations with getting adequate or consistent coverage. And I want to talk about some strategies to help improve performance and hopefully get rid of some of those frustrations. Like I said, we're going to spend most of our time talking about wireless, but I do want to talk about wired networks within the home. Wired networking is an option for home networking. I want to talk a little bit about setting up and installing wired Ethernet networking in the home. It is not as impossible as you might think. And then I want to end the presentation talking about a fairly new development in home networking, and that's installing computer networking over existing power lines. This could very well be the future of home networking, and as a matter of fact, I believe that this is going to be a standard feature of home networking in the not too distant future. There are some important considerations regarding security in installing networking over power lines, and I do want to talk about those when we talk about power line networking. So that's the agenda that I have for today's presentation. And I want to start the presentation by talking about the router, because the router is the most important part of a home network. In most home networks, the router will be directly connected to your broadband modem, and then all of your internet devices, your computers, your printers, your tablets, your smartphones, they're going to access the modem through the router. Most home networking routers also include a wireless access point. This is what allows your smartphones and computers to access the router. The wireless access point sends and receives data over a radio signal that cannot be hidden. I'm going to emphasize this point several times in this presentation. Your router with the access point is broadcasting a radio signal. There is no way to hide this radio signal. you will see some documentation in some home routers that say, yes, you can hide the signal. They are wrong. They are absolutely wrong. There is no way to hide your router's radio signal. And again, the router is the most important device in a home network. I'm going to be talking a lot about routers today. And I believe that the home router is as indispensable now in the modern home as the microwave oven. Can you live in a home without a wireless router? Of course you can. But in terms of having an internet access in the home, it is becoming more and more indispensable. Some home networking terminology, which I'll be referring to in this presentation. A LAN is a local area network. A home network is a LAN. WAN begins with a W. That's a wide area network. In other words, the internet. So your LAN, your home network, connects to the WAN, the internet. A wireless LAN, or I think it's a really odd term, Wi-Fi. Those are terms for a wireless LAN. Ethernet is the dominant technology. It's not the only technology for communicating data over LAN cables, but it is the dominant technology for doing that. The number's 802.11. You're going to see these numbers quite frequently when talking about wireless networking. What 802.11 specifically refers to is a technology standard developed by the IEEE, developed and maintained by the IEEE. Because these standards, the 802.11 standards developed by the IEEE, were designed to work with Ethernet, it's often referred to as wireless Ethernet. A few more terms for you. A router, again, it's the most important device in a home network. Among its many other functions, it allows multiple devices on your home network to connect to the internet. Access point, I'm going to talk a couple of different times about access points. An access point is a device that transmits and receives data for a wireless network. Most home networking routers include an access point within the device. A few more terms. A hub is a device that connects devices to a LAN. A switch is similar to a hub, but it has a little more intelligence and operates much faster than a hub. A bridge is a device that is used to connect and translate between two dissimilar LAN technologies. When we talk about Powerline networking late in this presentation, you need a bridge to communicate between a Powerline network and an Ethernet network. Two terms related to security. A war driver. A war driver is a person who searches for unprotected wireless lanes. Sometimes they'll be driving in a car and they'll have a little device in their car, and their device is looking for unprotected wireless lanes. And a piggybacker is someone who accesses a wireless LAN without permission. One of the objectives in a wireless security is protecting yourself against war drivers and piggybackers. I'm going to be talking about that quite a bit when I talk about security. So that's some wireless terminology for you. Let me talk a little bit about wireless networking setup. Fortunately, most wireless routers, I just replaced my router at home 2 weeks ago, and they are literally, you pull them out of the box and within 5-10 minutes, your router can be up and running. They're very easy to set up. They usually come with printed documentation, a quick start guide, which walks you through the basics of how to set up your router. They tend to be very easy to set up. However, there is one thing that you absolutely need to do the minute you set up your router. And it is the first commandment of wireless security. The first commandment is, thou shalt change thine administrative password. The minute you turn on your router, the minute you access your wireless router through the instructions given in the Quick Start Guide, change your administrative password. This is absolutely critical. Most routers allow remote administrative access over the internet to your router's configuration page. If you do not change your router's admin password, a hacker with malicious intent can access your router, and once they have administrative access to your router, they've got everything. Change your administrative password. Make it a good password. Don't make it password. Don't make it blank. Make it a good password. And a little bit later in the presentation, I'll give you a little advice on how to make remembering that password a little bit more convenient for you. But again, this is the first commandment. Change your administrator password, the first opportunity that you have. Okay, that's the first commandment. Here is the second commandment. Thou shalt enable encryption on thine wireless router. Now, I realize I'm probably not using my old English grammatically here, but it probably should be thy wireless router instead of thine, but I kind of like the sound of thine better than thy, so that's why I chose thine. But seriously though, enabling encryption on your wireless router is not an option. I've mentioned this before and I'll say it again. Your router communicates by broadcasting a radio signal. It is not possible to hide this radio signal. Your radio signal is out there. It can be intercepted by anybody. Because it can be intercepted by anybody, the only reliable way for protecting your wireless LAN is to encrypt that signal. If you've got an encrypted signal on your wireless LAN, yes, it can be intercepted, but if you've got a good passcode, that intercepted transmission will not be useful to anybody. I haven't seen any evidence of this yet in the United States, but there has been a case in Germany where someone left their wireless network unencrypted. It was an open system. Anyone could join it. And a little bit of details on this case. What happened is somebody went on this person's wireless network and then downloaded some music illegally. They broke copyright by downloading music illegally. The artist who had the copyright on that music, first of all, he went after the person who downloaded the music illegally, so they got him. But the artist also went after the owner of that wireless LAN. The argument being that by having an unencrypted wireless network, that the owner of that network was allowing or enabling the pirater to do his business. The court's decision in this case in Germany was that, yes, the owner of that wireless network was liable, and he faced a fine of $100 for allowing open access to his wireless LAN. So if you're in Germany and you have an unencrypted LAN, you could be subject to a fine. I haven't seen evidence in this in the United States yet, but I think this is coming. Okay. I want to talk a little bit about how to enable encryption. When you go into the wireless security settings, you're going to see a couple of different, several different options for what's sometimes called security mode or encryption type. You'll see options such as WPA2 or WPA. You'll even see options for WEP. Wherever possible, choose the encryption type of WPA2. Sometimes you won't have that option. Sometimes you have to choose WPA. And usually what's driving your decision about your encryption type is not so much the routers. Most modern routers will support all three types, WPA2, WPA, and WEP. But what may drive your decision are your client devices. I'm talking about your tablets, your computers, your smartphones. Some of the older mobile technology will only support WPA or WEP encryption. If that's the case, then you have to downgrade the security mode on your router. Where possible, choose WPA2. Regardless of your choice, WPA2, WPA, or WEP, the basic working of the security protocol is the same. You make your selection, you select your security mode on your router, then you enter an encryption code. This is similar to your passwords that you would use for your user accounts. You put in a security code in your router's configuration page. And then what happens is that on your client devices, your smartphones, your computers, your tablets, you have to connect to your wireless network and also enter the encryption code that you entered in your security settings. This is a one-time entry. Your device will remember the encryption code the next time it connects to your wireless network. Important bit of advice when you're enabling encryption for your wireless network. The newer wireless routers will feature what's called dual band or sometimes tri-band configurations. These are routers that can communicate on both the 2.4 and 5 gigahertz frequency bands. I'll talk more about what those numbers mean, 2.4 and 5, a little bit later. But if you have a dual band or tri-band router, make sure you enable encryption on all of your communication bands. If you're not paying attention and you're setting up wireless networking on your new router, you may set up encryption on the 2.4 band, but if you don't set it up on the 5 gigahertz band, well, you've opened up a vulnerability, or you've left a vulnerability open on your wireless router. So if you've got a dual band or tri-band router, make sure all of your bands are encrypted. Many routers also have a feature called a guest network. The guest network is an internet-only network provided by your wireless access point, by your wireless router. If you have, like on my network, I have a network-attached storage device. And we also have network printers on our home network. When we have friends over and we want to give them internet access, we don't necessarily need to give them access to our network-attached storage device. They also don't need access to our printers. So in that case, we'll give them access to our guest network. Our guest network is also encrypted as well. It has a different password than the password for our regular wireless network. But it's important to enable encryption on your guest network if you choose to offer a guest network on your wireless network. A little bit about a security feature called WPS. WPS stands for Wi-Fi Protected Setup. It is a feature which simplifies the process of adding devices to your wireless network. The way it works is that you press a button on the router. It'll either be a physical button on the router itself, or it could be a button on your router's administrative page. You press that button and your router goes into search mode, it's searching for WPS clients. After you enable search mode on your router, you then go to the new client device that's not part of your wireless network yet, and then you either press a button on that device or you enter a PIN code. So that is a way of adding devices to your wireless network without having to use an encryption key. Okay. The early implementations of WPS were vulnerable to hacks, and the feature has become more secure over the years, but if you go on some forums now about biosecurity, you're going to still see people who say, don't use this feature. I think this feature is okay to use. WPS is okay to use. However, change the default PIN code. There will be a default PIN code for your router. Just change it to something that's not the default. And again, the reason for that is hackers are going to know what the default settings are on routers. So if you're using the defaults, you're leaving open a vulnerability that's very easy to exploit. Okay. I've talked about the two commandments of wireless security, and those are changing your administrator password and enabling encryption. Now that we've talked about those two commandments, which you are going to follow if you're setting up your home network, right? Now that we've established what those two commandments are, I want to talk about what I consider 3 myths about wireless network security. Now, let me qualify this a little bit. The features that I'm going to describe, they do add some level of protection for your wireless network. But what they don't allow you to do, what none of these 3 techniques allow you to do, is to not enable encryption. None of these techniques are a replacement for encryption. And in fact, if you use any or all of these techniques without encryption, you are opening yourself up fairly easily to a resourceful hacker with malicious intent. Your war drivers, your piggybackers, it's probably going to stop them because they're probably not trying to hack your network maliciously, and they're probably not that resourceful. But a resourceful hacker will be able to easily get past any of these 3 techniques, what I consider myths about wireless security. They're going to get past them pretty easily. The first myth is about turning off your SSID broadcast. Okay, what is SSID? Your wireless network will have a name to it. Often the default name that comes with your router will be something, it's usually the manufacturer of the router. So if you have a Linksys router, the default wireless name, the SSID will be Linksys. If it's a D-Link router, it'll be D-Link. So this wireless network name is actually referred to, the technical name for it is the Service Set Identifier, or SSID. By default, what your wireless router does is that it broadcasts SSID out over its wireless signal. It's basically your wireless router is introducing itself to the world and said, "Hi, I'm a wireless network, and my name is," kind of like if you imagine, you're at one of those, you're at a cocktail party and everyone's got one of those name tags that you put on your lapel. "Hi, my name is," and whatever your name is. That's what basically an SSID does. It's your router's way of introducing itself to the world. I'm a wireless network, and here is my SSID. You have an option with most wireless routers to turn off the SSID broadcast so that your wireless network isn't going around saying, "Hi, my name is," whatever my SSID is. If you look at the documentation on some wireless routers, and what I have on this slide is a screenshot of my online documentation for one of my old routers. The router documentation will refer to this turnoff of the SSID broadcast. They'll refer to it as hiding your network signal or making it invisible. I believe that's how, yes, it's the invisible option. So if you go on some home networking forums, you'll see this as a recommendation. Turn off SSID broadcast. It hides your wireless network. Okay. Does it really make your wireless signal invisible? No, this does not make your wireless signal invisible. If you turn off SSID broadcast on your router, it is still transmitting a radio signal. That signal can still be detected by devices that search for Wi-Fi signals. If you disable SSID broadcast on your router, are you going to be able to frustrate war drivers and piggybackers? Well, if they're not very resourceful, you probably will thwart them by turning off your SSID broadcast. But a determined, resourceful hacker with malicious intent is not going to be stopped for a second by turning off SSID broadcast. They're going to find out what your wireless network name is. To use the analogy I used before, okay, so your wireless network no longer has a name tag on its lapel. It no longer has a, "Hi, my name is," whatever my wireless network name is. It no longer has that lapel. However, but if you can think of someone entering the room where this party is going on, and that person goes up to your wireless network and says, "Hi, what's your name?" Your wireless network is going to tell you what the name is. So turning off SSID broadcast, it doesn't make your wireless signal invisible, despite what router documentation may say to the contrary. So that's the first myth. Another myth about wireless security is using a feature called MAC filtering. Okay, what does MAC stand for? This is not the Mac referring to Apple computer. This is referring to a component of networking hardware called the Media Access Control address. MAC stands for Media Access Control. If you're on a Windows computer and go to a command prompt and type in the ipconfig --all command, you will see a physical address amongst the many lines of data that you'll see. The physical address is the MAC address of your computer. Every device, every networking device will have a MAC address. Your laptop has one, your smartphone has one, your tablet has one. Most routers will allow you to restrict access on your network to a defined list of MAC addresses. So if you wanted to, if you got the MAC address of all your mobile devices, you could go into your router's configuration page, enter those MAC addresses, and say, only these MAC addresses can have access to my wireless network. When I first heard about this feature, I was excited. I thought, this is wonderful. Oh my gosh, if I can just say my, however many, 15 devices that I have on my wireless network, those are the only ones that can get into my network. And MAC addresses have to be unique. It's one of the requirements. Oh my gosh, how secure is that? I thought this was the coolest feature in the world, and I actually employed this for about a year when I set up my first wireless network. Okay, before I debunk that myth, let me talk about myth number 3, disabling DHCP. What is DHCP? I should have added this definition in this presentation. DHCP stands for Dynamic Host, I believe it's Control or Configuration Protocol. But every computer on the internet has to have an IP address. I think you all are knowledgeable enough to know that every device on the internet has to have an IP address. And DHCP is a service provided on wireless routers so that when a device on your wireless network accesses your wireless network, it is given an IP address by your wireless router. Instead of using DHCP, which is a very convenient feature to use, you can disable DHCP and manually assign IP addresses to your mobile devices by using the MAC address that you talked about before. So in addition to saying only these MAC addresses can access my network, and each MAC address will have this specific DHCP, IP address. Those are two things that you can do to add some more security to your wireless network. And again, this is a feature that I employed. I turned off DHCP on my first wireless network. In addition to using MAC filtering, I thought this is a way of locking down my network and preventing anyone that I don't want, who I explicitly don't give permission to access my network. This is a way to really lock down my wireless network. However, by enabling MAC filtering and or disabling DHCP, does this work? Does it really lock down a wireless network? Well, after doing some research on this topic, I came to the conclusion that, sorry, it doesn't really offer as much security as it ostensibly would seem to. Okay, I'm going to say this again. The wireless radio signal on your router can never be hidden. There's no way to make it invisible. If there is a determined resourceful hacker within range of your wireless network, and you have not encrypted that signal, it's fairly easy for that hacker to extract the IP and MAC address information from your wireless signal. Once a hacker has MAC address and IP address, it is fairly easy for them to spoof this information. Even though the hacker's device has a different IP address and MAC address, it's fairly easy for a hacker to use software to say, this is my actual IP address, this is my actual MAC address. A MAC address and IP address that are legitimate on your network. They can spoof that information. Once they have that information spoofed, the hacker's device looks like a legitimate device on your network. they've got access to your wireless network. Okay. Those three features I've talked about, disabling SSID broadcast, enabling MAC filtering, manual IP address assignment, they do provide a certain level of additional security. However, there is significant administrative overhead required for each of these features. And the advantages that they offer, I believe, do not justify using these features. Because again, the malicious hacker who's resourceful and has malicious intent will be able to get around all three of these devices fairly easily. So in this slide, I've brought in Moses. Moses has his 2 tablets, and we don't see the commandments on these 2 tablets. I want to reiterate the 2 commandments of wireless security. Change your router's administrative password and enable encryption. You have to do these 2 security processes in order to have, in my opinion, a wireless network. All right, so having a robust encryption code for your wireless encryption, that can be a little bit difficult. If you've got a password that's difficult to remember and you have a friend come over and you want to add them to your network, if you've got a 20-character password, you may not be able to remember that off the top of your head. Here's a tip that you can utilize to help ease the administrative difficulty of enabling encryption on your wireless router. What you can do is on the bottom of your router, and what I have on this slide is a picture of the bottom of one of my old routers. And what I have on the bottom of this router are 2 pieces of electrical tape. And on these pieces of electrical tape, I have written down my wireless network name, the SSID, and my encryption passcode. The examples I give here, I just kind of made up. Those are not actual, that's not my actual wireless name. That's not my actual passcode. I would never use a passcode that was that easy to figure out. But the point here is that if you have this information on the bottom of your router, you have this information immediately accessible, so that when your friend comes over and you want to remember, okay, what's my wireless network name and what's my passcode, you flip your router over, there it is. And the beauty of this is that this information is completely invisible to external threats. A hacker is not going to be able to physically look at the bottom of your router unless you invite the hacker over, which, well, if you're inviting hackers over to your house, you've got problems that wireless security can't solve. Anyway, little tip for making wireless encryption a little bit easier to implement for you. Okay. Let me talk a little bit about some recommendations on improving wireless performance. If you have a wireless LAN in your home, you've probably noticed that you've got some dead zones and some areas where there's really hard to get signal. In the illustration I have on the right-hand side, we have, you can probably see the router in the middle of the blue circle. It is at the, on the back of the house in the dining room. And you can see the blue circle represents the effective range of this router. And you can see that we've got pretty good coverage in the great room. We've got pretty good coverage in the dining room and even the kitchen. But when we get to the living room, and especially the den or guest room at the front of the house, wireless reception is hard to get, and in the den guest room, there is no wireless coverage. So what can we do to improve performance, to get coverage to more areas of our house? Couple recommendations. The most important one, location, location, location. If this is an option for you, moving your router is probably the best thing that you can do to improve wireless performance in your dwelling. Place your router, if possible, in the most central location of your dwelling. If you're in a two-story home with a basement, put it on the first floor. Try to put the router also near the center of the house. In the revised diagram I have here, what we've done is that we've moved the router from the dining room into the great room. And we've put it at the corner of the great room that's closest to the front of the house. By doing this, we still have pretty good coverage in the great room and the dining room. We've probably compromised wireless reception a little bit out to the deck. I believe that's a deck outside the great room and dining room. So we may get a little bit less performance out to the deck. But what we've done by moving the router is extended coverage to the living room and to the den guest room. So now sometimes moving a router is not an option for you. Sometimes you're limited by where your broadband signal comes into the home. If you only have one or a couple of areas where you can install your broadband modem, then this might not be an option for you. But if it is, that is probably the most important thing you can do to improve performance. Another recommendation about improving wireless performance is, if it's an option for you, use the 5 gigahertz frequency band on your wireless router. Okay, a little bit about frequency bands. Okay, I mentioned before about those numbers 802.11. You've probably seen references in and networking products to 802.11g, as in girl. 802.11g and older wireless technologies communicated over the 2.4 gigahertz frequency band. This is a band used by many other household devices: microwave ovens, cordless telephones, baby monitors, garage door openers. All of these home devices use the 2.4 gigahertz band. If your wireless network is also transmitting over the 2.4 gigahertz band, that's probably what's causing a lot of interference and disruption of your wireless signal. I've noticed in the past that on my old wireless network, sometimes my wireless signal would go out when we were making popcorn in the microwave oven. Newer wireless routers that use the 802.11n, N as in night. If it uses the 802.11n standard, that standard has the option of communicating over the 5 gigahertz frequency band. There is much less traffic over the 5 gigahertz frequency band. Now, the thing about using the 5 gigahertz frequency band, not only your router, but also your mobile devices have to support the 802.11n standard to communicate over the 5 gigahertz band. If that's an option for you, communicating over 5 gigahertz can help improve your wireless network performance.
Ken, just want to remind you, you got about 5 minutes.
Okay, thank you. All right, so a couple other recommendations. If you haven't upgraded your router in a couple of years, it's probably time to look at it. The technology is getting better. They're adding features to it. If you're looking to replace your router, good replacement will cost between $80 and $120. If you want the latest and greatest feature, you're up to around $200. Beware the bargain basement. If you're spending less than 80 bucks for a router, that's probably not a good price. Okay, tech specs, the latest commercially available router uses the 802.11. We're up to two letters now, AC, as in AC/DC. 802.11 AC. It's still a little expensive at this point, but the performance over 802.11n, which is the next generation before it, there's a noticeable difference in performance. 802.11g I do not recommend anymore. It is yesterday's technology. Look for routers that can communicate over both 2.4 and the 5 gigahertz bands, and get as many antennas as possible. They perform better, and gosh, they look cool. Okay. Wireless range extenders. Basically, what a wireless range extender does is that it picks up your wireless signal and transmits it to more areas of your house. If you go on wireless networking forums, you're not going to see a lot of enthusiasm for wireless range extenders. This diagram here illustrates the problems with them. Your range extender has to be within range of your wireless router. It doesn't work if it's not in range. But because it's in range, what it's doing is that it's creating a significant amount of signal overlap between your router and your range extender. Yes, this approach will work. It adds coverage to the den, guest room, and the living room, but we're creating a lot of interference, a lot of additional network traffic within the dining room, especially. So there are drawbacks to using range extenders. A more desirable option to a range extender is installing a additional access point. And in this illustration, what we have is we have an access point added in the den guest room. It provides coverage to the den guest room and the living room, and the amount of signal overlap is greatly reduced between the access point and the router. Okay, so how do you install that access point? If you go on YouTube, you will see a gazillion guides, how-to guides about installing Ethernet cabling in your home. If you have a drop ceiling, either above or beneath where you want to install the cabling, it makes installing Ethernet wiring a lot simpler. Hard part about installing Ethernet wiring is running the cables between rooms of the house. That's the difficult part. Once you have the cabling routed between rooms of the house, making the outlets is actually kind of fun. And again, there are several YouTube videos out there on this process. We've got just a few more minutes. I want to talk a little bit about non-wired Ethernet networks, and specifically about what's called Powerline Networking. Powerline Networking is the ability to use your home's electrical wiring to transmit data. I believe this is the technology of the future. In the very near future, you'll be able to plug in your new appliance and have it immediately connect to the internet through the use of Powerline Networking. I really think this is coming. We keep talking about the Internet of Things, about having your refrigerator and your toaster on the internet. I believe this is coming, and I believe Powerline Networking is going to drive it. There are some big security concerns with Powerline Networking, especially if you live in an apartment or some community that has shared electrical service. Powerline network devices, yes, they come with encryption. You can encrypt your your Powerline network, but if you're using the default Powerline network name and the default Powerline network password, your hackers are one plug away from accessing your entire home network. If you have a house that doesn't share electrical service, but you have an external outlet, and I've got plenty of external outlets in my house. If you enable Powerline networking and don't change the defaults, the hacker's going to know what the defaults are. They're one plug away from accessing your home network. So if you use Powerline networking in your home, change the defaults. Very important. Okay, so again, I believe Powerline networking is going to be a standard feature of home networks in the very near future. And I believe home networking technology, the wireless networking is going to continue to improve in both speed and performance and security in the future. So,
okay. Thank you very much, Ken. As I said,